All right, so you know how when you think about crystals, you kind of picture like something, pretty static, right? Just sits on a shelf, catching the light.
Yeah, like pretty sparkly, but pretty much unchanging.
Exactly. But what if I told you there are crystals being studied right now at the University of Cincinnati that can bend and twist and bounce and even explode when you shine a light on them?
Whoa, okay, that sounds a little less like my grandma's crystal collection.
Right. So today we're doing a deep dive into the research of Professor Anna Gudmundsdottir and her chemistry students who are working with these wild photoexplosive crystals, and we're pulling all this from a recent report on their work.
And this isn't just about some cool lab tricks. I mean, we're talking about potential applications that could change how we think about safety in air travel and even support future space travel.
Yeah, it's pretty mind-blowing stuff. And what's really fascinating is how new this all is. The report really emphasizes that. Like Professor Gudmundsdottir says, we're studying what makes crystals behave when exposed to light. We can make them jump, explode, or dance. They do all kinds of weird things.
So weird is putting it mildly.
Yeah. And this report goes into some really vivid descriptions of these crystals in action. Like, picture this, some of these crystals bend at their ends with enough force to actually lift objects many times their own size.
So we're not talking about just like a little bit of bending. These things pack a punch for their size.
Yeah. It's kind of like they're flexing some serious micromuscle. And the report says some of them can even twist into these helix shapes. They can do a full 360-degree rotation.
And some of them even hop right off the microscope slides. So not just strong, but a little jumpy, too.
It's crazy, right? You wouldn't think a crystal could be so lively.
Yeah, makes you think about crystals in a whole new way.
And the report quotes one of the UC doctoral students, Fiona Wasson, who says she's particularly fascinated by the fact that the same molecules can make totally different crystals. And depending on how those molecules are packed together, they react to light in completely different ways.
Yeah. That's like saying you can rearrange the same Lego bricks to build a house or a spaceship. Like, the building blocks are the same, but the final product and what it can do is totally different.
Right. So let's get into the why here. What's actually making these crystals move and groove?
So the report explains Professor Gudmundsdottir's theory. Basically, when these crystals are forming in the lab, they trap tiny bits of nitrogen from the air. And when light hits the crystal, it gives it the energy to basically kick out that trapped nitrogen.
Oh, okay, so it's like a tiny explosion, kind of.
Yeah, exactly. Like a mini burst of energy that makes the crystal move.
That makes sense. And to study these explosions, or at least capture them, the team had to get pretty creative.
Oh, yeah. The report talks about this special darkroom they built just for this research. One of the students, Ben Miller, spent a whole semester in there, basically learning how to photograph these tiny crystals while they explode. They had to use red lights to focus the cameras first because the crystals react to light, so they couldn't just turn the lights on. Then they would expose the crystals to different LEDs and try to catch the action.
Wow, sounds like a super delicate process.
Absolutely. And the report also mentions that Miller made another really cool discovery. He found that some of the crystals that bend, you can also just bend them yourself with tiny tools.
Whoa, really? So it's not just the light making them bend?
Right. And he says, and I quote, "What's cool about it is it bends, and when it snaps back, there's no damage to the surface or anything. That's pretty unique for crystals. Most crystals, if you try to bend them, they just crack."
That's incredible. They're like super flexible crystals. I also loved what Miller said about the whole experience. The report quotes him saying, "Sometimes I think I know something about science that nobody else knows," and that's very interesting.
Yeah, you can totally sense the excitement of discovery. It's awesome.
Totally. So we've talked about crystals that bend and twist once, but the report also mentions crystals that can repeat these actions.
Right. And this is where things get really interesting in terms of potential applications. Professor Gudmundsdottir says, and this is from the report, that this repeating motion could be used to create light-powered muscle fibers. Like, imagine materials that could contract and expand just by shining a light on them.
Wow, almost like tiny little light-activated robots.
Yeah, exactly.
Yeah.
Or they can make super-sensitive sensors that react to even tiny changes in light. It's like a whole new way of thinking about how materials can interact with their environment.
It's mind-blowing. But the potential doesn't stop there, right? There was also talk about using these crystals for oxygen.
Absolutely. Professor Gudmundsdottir has this vision, and the report details this, for crystals that could actually release oxygen when you shine a light on them. Think about how that could revolutionize oxygen safety systems, especially in things like airplanes. If there's a loss of cabin pressure, you could have these lightweight, light-activated crystals that release oxygen.
So much safer and more efficient than the systems they use now.
Exactly. And, Fiona Wasson, the student we mentioned before, she brought up space travel.
Oh, right, because in space you have, well, a lot of space, but also a lot of sunlight.
Yeah. And she points out in the report, there is lots of light in space. So these crystals could be really useful for future space missions, maybe even help generate oxygen or power systems using just sunlight.
It's incredible to think about, We're just scratching the surface of what these crystals can do. And the report makes it clear this isn't just some small side project. This research has some serious backing.
Yeah. The National Science Foundation awarded them a $550,000 grant to keep exploring this stuff. So clearly, there's a lot of interest in where this could lead.
So just to kind of bring it all together, we've got these crystals that bend, twist, bounce, explode, all thanks to this cool trick with trapped nitrogen. And this research isn't just about the wow factor. We're talking about potential applications that could make air travel safer, push the boundaries of space exploration, and even change how we think about materials science altogether.
It's pretty inspiring stuff. And as you can tell from the report, the researchers are super jazzed about all the new things they're finding. It's a great example of how even materials that we think we understand, like crystals, can still surprise us.
It really makes you think about what other seemingly ordinary things around us might have these crazy hidden abilities. Like, what if we just haven't found the right way to unlock them yet? Definitely something to ponder.
Totally.
Yeah.
Like, what other secrets are hiding in plain sight, just waiting for the right light bulb moment?
Exactly. Thanks for diving in with us. Until next time.
See you then.